Hello, everyone. Good morning, good afternoon, and good evening. Thank you for joining us to learn more about the new capabilities announced in Horizon Catalog today. In this session, we will quickly talk about our vision for Horizon Catalog and deep dive into specific capabilities we are adding to it. First, a quick introduction about myself. I am Raja Balakrishnan. I lead a product management team responsible for governance, privacy, and interoperability capabilities in the Horizon Catalog. First and foremost, today, we are very excited to announce that Horizon Catalog is now fully interoperable with open APIs, specifically Apache Polaris and Iceberg REST Catalog APIs. This means that you can now take advantage of the best Snowflake capabilities on your open data lake without any lock-in. By unifying Iceberg interoperability, governance, data discovery, Horizon Catalog is now the universal AI catalog over all your data. Specifically, Horizon Catalog now enables you to work with any engine, any data format, anywhere. Concretely, Horizon Catalog offers four unique benefits to our customers. First, it provides interoperability without lock-in by enabling a lakehouse architecture that integrates open formatted data from disparate systems. Second, it provides enterprise-grade security and governance for data and AI, specifically role-based access controls, attribute-based access control, and granular access policies for data and AI. Third, it provides context about the data to enhance AI readiness of your data. And finally, Horizon Catalog provides organization-wide management across regions and clouds for seamless business continuity and disaster recovery, BCDR in short. Now, let's start our deep dive with the big new announcement we made today. First, like I said earlier, I'm excited to share that Horizon Catalog will offer interoperability to read and write open table formatted data from external engines. As you know, choosing Iceberg as your open table format has benefits such as maintaining a single copy of data that is accessible by multiple engines. The key technology behind today's interoperability announcement is Iceberg REST Catalog APIs, or IRC, that is now embedded in Horizon Catalog. This enables Horizon Catalog to support reads and writes from other Iceberg engines. This is a big benefit for Snowflake customers since their existing users, roles, grants, and RBAC controls are seamlessly applicable to even external queries on the Iceberg tables. Many of our enterprise customers care about private link for security purposes, and all authentication integrations and private link capabilities are now applicable for external queries as well because of this interoperability. Beyond security and authorization benefits, Horizon Catalog automatically takes care of Iceberg maintenance activities such as table maintenance. We also plan to offer Snowflake managed storage for your Iceberg tables to further make it easier to use Iceberg with Snowflake. It is important to note that all of these interoperability capabilities are possible due to Snowflake's and the community's investment in Apache Polaris. Apache Polaris provides an additional benefit to customers. There is no lock-in, since customers can now move their catalog to Polaris OSs if needed. Now, let's see all of this in action with a demo. Let's first start with the Horizon Catalog in the Snowflake interface. Here, we have created a database just for a few Iceberg tables for the sake of this demo. One thing that you don't see here is we will use the data engineer role to do read-write operations from both Snowflake and external engines. But first, let me show you in the data preview here that we have 10 records in this table. We will also talk about data masking, but that is something that I'll come back to at a later point. Okay, with this all set, now let's switch to a Jupyter notebook, which will be our external Spark client for today's demo. Before we go too far, I want to go to the top there and show you a few things. If you scroll up, you will first see the URI or the URL. This is the new IRC endpoint on Horizon Catalog that is making all of this possible. Next, you will see a token. This is the authorization token that is required to authenticate and authorize the Spark client to Horizon Catalog. For simplicity's sake, I have pre-authenticated the Spark session using the Data Engineer Access token from Horizon Catalog. With all the setup out of the way, let's execute a few queries. First, let me execute a simple select count star from the Iceberg table that we saw earlier. Okay, notice that we can now access the 10 records that we noted earlier within Horizon. We are able to access the data since Horizon Catalog manages credential vending to the storage layer in S3 to access this data. Now, let's move on. We can go further than reading the data. We can actually modify the table schema. To show that, let's alter and add a column. Okay, that was successful. And finally, let's insert a record into this table. Notice that a select count star now shows 11 records. We saw 10 earlier, we were able to read it, and now we inserted a record, and now we can see 11 records. So that brings us to the end of the demo. To summarize, Horizon Catalog supports both external reads and external writes from engines that support Iceberg standards, while leveraging Snowflake's users, roles, and RBAC controls. But it actually gets better. Since Iceberg interoperability is a core part of Horizon Catalog, customers can now centrally and scalably control access to Iceberg tables using attribute-based access controls such as PII tags on sensitive columns in Iceberg tables. Snowflake's granular access policies are now relevant for Iceberg tables. With the appropriate configuration controls, access policies can be enforced even with queries from external engines. Horizon Catalog can provide interoperability and governance no matter where your data lives or which engine accesses it. This will become more clear once we see a demo of this in action. As a data governor in Snowflake, I want to add a masking policy to the email column so that only account admin users can see the email columns. As you can see in this example, right now, anybody, including the data engineer, can actually see the email addresses unmasked, and that's exactly what we want to change. And like I said earlier, as a governor, I want to use attribute-based access control, specifically tag-based masking. So I'm going to create a masking policy, a tag, a masking policy, and also assign those to the email column, as you can see here. So let's quickly execute all these commands. And while that's happening, I want to highlight that tag-based masking is an important ABAC or attribute-based access control capability in Snowflake that enables you to scale fine-grained access to sensitive data. Okay, so all the statements are now executed. Now let's go back to the Jupyter notebook that we saw earlier. We haven't changed anything. We're still using the data engineer role, But let's now execute, let's now query this table, do a simple select star, and see what happens now that we have assigned a masking policy to it. Okay, so there it is. As you can see here, we have queried the exact same table using Data Engineer from an external engine, but the email addresses are now masked, right? Now, an important point to note here is that fine-grained access control policies are not yet part of the IRC specification. So we are intelligently routing protected tables to be read via the Spark Snowflake connector to ensure that external engine queries are still protected by Snowflake governance policies. So with that demo, let's switch gears to sensitive data discovery. Now, in today's rapidly expanding data landscape, sensitive information is constantly being created, transmitted, and stored, often creating security blind spots. It is crucial to not only know where your sensitive data resides, but to also know whether it's adequately protected. This isn't just a best practice, it's a vital requirement across many industries, specifically financial services, healthcare, technology, to maintain compliance with evolving regulatory requirements. So today, we are excited to announce a new experience in Trust Center that focuses on sensitive data posture management, or DSPM in short. This new experience brings together the well-established data governance products such as automatic sensitive data classification, object tagging, and tag-based masking policies into one unified experience and flow. It greatly simplifies the end-to-end journey by automatically and continuously discovering sensitive data as and when they come into the system. Two, by providing a bird's eye view of where sensitive data is located in your entire account. And finally, by providing granular information of showing what is protected and what is not protected. All this will become very easy to understand once I show you a demo to better understand how all this comes together. Before we go into the data security product, or DSPM, I want to first call attention to the left navigation here in Snowsight. We have updated it with Horizon Catalog capabilities. Here, you'll find that data catalog and governance and security capabilities are nicely arranged under the Horizon Catalog pillar. Now, for this demo, let's use the Governance and Security tab to navigate to the Trust Center. Here, notice the new tab called Data Security. This tab focuses on sensitive data detection at scale and manages its protection posture. Now, let's start by looking at this dashboard. This dashboard is what I was talking about earlier. It provides a bird's eye view of all sensitive information in your account. We can first start by showing you what a first day experience would look like for configuring the data security posture management product. To do that, let me first start by going to the settings aspect of DSPM. Now, there are two ways in which you can configure sensitive data monitoring. The first and simpler way is to just look for the Snowflake default profile and make some updates to it. Specifically, you can choose all the databases that you want to monitor. That's the first step, and then you can choose to apply the tags when we find a sensitive data category. Now, the idea of this is to make it very easy for you to get started. All you need to do is enable, and you can we will start monitoring all your tables for sensitive information. Now, for more advanced cases, you may want to create your own classification setup. And we have made that easy too, but here you get a lot more customizability. Specifically, you can select the databases that you want to monitor, and remove any other database that you don't want to monitor. For example, this could be your production database that you want to monitor and your test database, maybe not so much. And secondly, we will automatically look for various categories of sensitive information, such as social security numbers, passport numbers, and many more. In fact, we look at 100 types of sensitive data types out of a box. But the most interesting part here is you can bring your own classifiers, for example, medical codes, insurance ID, things that are not standard but are specific to you. You can add it to the classification process. And finally, in addition to the default tags that Snowflake can apply, you can bring your own tag. Maybe in your environment, you want to add a special tag called classification, and you want to choose that whenever you have, for example, a bank account show up, right? Whatever it is, you can customize what you want to look for and how you want to tag it. And the last step really is to determine the cadence. How frequently do you want us to do this operation? And are there any exceptions that you don't want us to look at, basically, and exclude? Right. So hopefully this gives you an idea of the robustness of how much you can look into your data and what you can do when you find sensitive information. So with that context, let's go back, right? In this example, we have already set up classification. And here I want to call your attention to how the dashboard provides you information, right? You can get a very quick overview of things like email and which specific objects and columns contain email address. And even more importantly, by default, categorized all these indicators of sensitive information into compliance categories. For example, we've organized GDPR and we've identified all the different kinds of sensitive information which constitute GDPR. Now, the value proposition of this is you can simply drill in if you're looking for GDPR and get a much more detailed view of all the tables and the columns that contribute to your GDPR information. That's a first level of information. The second one, even more interesting, is you can further drill down to identify whether your GDPR information or any other sensitive information for that matter is unmasked or masked with the right protection policy. Now, this makes it very easy, for example, to say, to zero down on, let's say, in the last one day, whatever sensitive information was added, and if any of that data is really not protected. And as a governor, now this makes it super easy for you to focus your attention on the key things that matter, things that contribute to regulatory requirements and things that are not adequately protected. Hopefully, that gave you a pretty good idea of how easy it is to detect sensitive data at scale and manage its protection posture within Snowflake. Now, continuing down the theme of detecting and protecting sensitive data, customers often have petabytes of unstructured data, such as transcripts, medical notes, voice call records, and many more that contain valuable business insights. For example, analytics on call transcripts can be used to perform sentiment analysis and determine customer satisfaction. Over the last few years, significant advancements in AI and Snowflake's innovative approach of making AI accessible via native AI SQL functions have made this kind of analysis almost turnkey and out of the box. Having said that, unstructured data like call transcripts often contain the user's personally identifiable information or PII. Before using AI or any ML solutions to perform such analysis, it's imperative to redact PII to maintain the user's privacy. So today, we are excited to announce a new AI SQL function called AI underscore redact that you see on the screen here that will detect and redact sensitive information from generic unstructured text. This function can be used to make the data AI ready before leveraging it for your AI and ML initiatives. I'm happy to share that this function is right now in private preview and will soon be available in public preview for you to try it. In the next few minutes, I want to walk you through the latest innovations in everything we have done to help customers to gain deeper visibility and confidence in their data in Snowflake. Data observability is becoming a foundational capability for every data-driven organization. As data pipelines grow more complex and data becomes critical to decision making, customers are asking us for capabilities that not only monitor performance, but also proactively detect and help resolve data issues before they impact the business. So I'm happy today to introduce a new user interface in Snowsight, which includes automatic data profiling and an out-of-the-box dashboard for monitoring data quality. This interactive interface that you see here will provide various information such as the data quality metrics, the trends in the quality, and specific incidents that might be triggering those data quality issues. The UI enables you to drill down into failures such as a failed data quality check and helps you assess the downstream impact of that failure and, more importantly, identify specific records that violate a data quality expectation or data quality check. In addition to the user interface and data quality monitoring, we are making continuous investments in making sure that data quality is even more intelligent to help you achieve your goals. Concretely, we recently launched an anomaly detection capability for data freshness and data volume so that you can automatically identify any sudden spikes or drops in data volume. With that, let's move on to external lineage. Data lineage has been an important part of Snowflake's data governance strategy. Also, because we understand that Snowflake is a part of a larger data estate and interoperability is key, we are extending Snowflake's native lineage capabilities to also include external data source information, specifically information or lineage information from data sources such as BigQuery, Redshift, Postgres, Databricks, SQL Server, and a few more through interactions with data engineering tools such as Airflow, Spark, and dbt. More concretely, we recently launched an open lineage compatible REST endpoint. By using this REST endpoint, you can ingest open lineage formatted lineage events from any external source to Snowflake. Lineage information from these external sources will now be automatically and directly surfaced in the lineage graph that you see in the slide here. The lineage graph will be displayed in Snowsight for all your end users to consume. So together, the updates in data quality and lineage help us bring Horizon Catalog's vision of providing a data platform where observability is built directly into the platform. Finally, I'm also happy to share that in addition to external lineage, we are bringing other types of metadata, specifically metadata about the data objects from relational databases such as Postgres, MySQL, and SQL Server. Because of this, customers can discover data in external relational databases and other external sources without leaving Snowflake. This feature is now in private preview. We hope that you found this session about Horizon Catalog and its various capabilities and new announcements to be helpful.